Hello everyone, my name is Jean-Luc Monsavoir. I've worked 30 years in Shell Company and now I'm a lecturer at IFP School. I will be your professor for the next subject, crude oil refining and refining processes. I have divided my lecture into two parts. In the first video, we'll take a look at the crude oil origins and crude composition, the different products we obtain, and the different applications of these products. We'll also see the specification required to sell the products. Finally, I will explain the main objectives of a refinery. Afterwards, in the second video, we'll see the different units or processes of a refinery used to convert crude oil into commercial products within the specifications. Let's start with the first part of my lecture. We will discover the refining, petrochemical and gas industries. In a nutshell, the objective of these industries is to transform the crude oil and the gas into final commercial products such as gasoline, diesel, plastics, natural gas to deliver to the consumers. The segment is also called the downstream segment of the oil and gas industry. The aim of this part of the MOOC is to provide you with the fundamental technical information needed to understand the various activities involved in transforming the hydrocarbons produced by the upstream segment, which means oil or petroleum and gas, into commercial products. As already seen this week with Isabelle, the oil is produced from the production wells. It is divided into three different flows in the separation drum: the gas, the water and the liquid oil. In this part, we'll study how the crude oil is transformed into different products in a refinery. Let's start with the raw material of a refinery, the crude oil. In the barrel of crude, you have approximately 85% of carbon elements, plus 10% of hydrogen. The barrel of crude is composed mainly of hydrocarbons, up to 95%, consisting of carbon and hydrogen. The other 5% are called impurities. On average, after the first treatments, seen with Isabelle, and depending on the crude origin, we find approximately 2% of sulfur compounds. The sulfur level of a crude is the key parameter for crude selection and crude prices. The higher the sulfur level in the crude, the more difficult it will be to treat the crude to obtain products with low sulfur specifications. In general, the higher the sulfur content of a crude, the lower the price. We find other impurities, including nitrogen, typically around 2%, water, salts and sediments, which could be present in the crude. Water and salts must be removed from the crude at the inlet of the refinery to avoid corrosion problems and fouling by salt depositions in the unit of the refinery. Now, we'll focus on hydrocarbon types that we typically find in crude. In crude oil, you can find naturally four types of hydrocarbons. First, we have paraffins. Paraffins are linear hydrocarbons made up of carbon and hydrogen atoms. Long linear paraffins are also called waxes. Second, isoparaffins, which are non-linear paraffins with one or multiple small groups of carbon and hydrogen attached to them. The third type of hydrocarbon is naphthene families. These hydrocarbons are composed of carbon and hydrogen linked together in a ring shape. The last family is aromatic compounds. Aromatics are hydrocarbons composed of rings of carbon and hydrogen, but with double bonds between the carbon elements. Compared to naphthenes, aromatics are, for the same number of carbons, less hydrogen. The first aromatic is called benzene, with 6 atoms of carbon. It is an important compound for the petrochemical and chemical industries. In conclusion, the crude oil is characterized by the paraffins, isoparaffins, naphthene and aromatic content. It is important to know the type of hydrocarbons you have in the crude, because these molecules will directly influence the quality of the different products you will obtain from this crude oil. Let's now look at the first unit of a refinery, called the crude distillation unit, or CDU. This unit is operated at high temperatures, around 360 degrees C at the bottom, and the pressure of 2 bar gauge. This first unit divides the crude into different smaller petroleum cuts, used as bases for everyday commercial products. At the top of the crude distillation unit, we have the lighter compounds, the lowest carbon number and the lowest boiling temperature. First, we have the gas with carbon numbers between 1 and 4. We find in this cut gases such as methane, ethane, propane and butane, which are used as fuel. Then we have the naphtha cut. The naphtha cut has a carbon number range between 5 and 6. This cut is the raw material used in the petrochemical industry to produce different types of plastics with different properties. You will study the petrochemical industry further with Céline and Michel next week. Next, we have the gasoline cut. It's composed of hydrocarbon with 7 to 11 carbon numbers. This cut is the base for the gasoline fuels used for spark ignition engines. The kerosene cut is the main base used to produce jet fuel, called Jet A1, delivered to all international airports. Typically, the carbon number of this cut is between 11 and 13. The next cut is the diesel cut, which is the base of the diesel fuel for diesel engines of cars and trucks. The hydrocarbon chains contain between 13 and 25 carbon numbers. This cut is also the base for heating oil used to heat buildings, houses and offices. The atmospheric residue obtained at the bottom of the CDU is treated in the second distillation column, called the Vacuum Distillation Unit, or VDU. This column is operated under vacuum around 80 millimeters of mercury and at a temperature of 360 degrees C at the bottom of the column. From this VDU, we obtain distillates as bases for lube oils and paraffins. Lube oils are used for the lubrication of car and truck engines, as well as for the lubrication of equipment industry. Finally, at the bottom of the vacuum distillation unit, we have the vacuum residue. This cut contains all the heavy hydrocarbons from the crude oil, with carbon numbers higher than 50. This cut is used to produce heavy fuels, for instance, for boats or power plants. It is also the base used to produce bitumen for roads and motorways. Now, to sell a product, it is important to check if it respects all of a series of technical specifications. Per product, the number of specifications can be really high. For instance, for jet fuel, there are more than 30 technical specifications to check before being able to sell jet fuel to an airport. We'll study together 5 important specifications. First, we'll describe the density, which is a specification used for all kinds of products like gas, gasoline, jet fuel, diesel oil, heating oil, heavy oil. The octane number is used to specify the gasoline for spark ignition engines for cars. Cetane is a specification for diesel engine. Sulfur content, which is an important specification for environmental concerns, for a lot of products from a refinery. And finally, we'll describe the cold flow properties of products. It is important to respect this specification in order to be able to start and run an engine in cold conditions, like in winter. Let's start with density. Density is a specification widely used to characterize petroleum products. It is expressed as the weight of a product per cubic meter of the same product. When the carbon number of a cut increases, the density has a higher value. For instance, the density of gasoline is lower than the density of jet fuel. Now, we're going to look at the octane number. The specification is used for gasoline engines. The octane number characterizes the knock resistance of the gasoline. In a spark ignition engine, after mixing air and fuel in the combustion chamber, the ignition is controlled by a spark. The knock phenomenon is an abnormal combustion. It consists of octoignition of the fuel at a non-optimum position of the combustion chamber, before the spark. This uncontrolled octoignition creates pressure waves which lead to vibrations. This vibration sounds like a metallic noise. It's called knock. The knock phenomenon can induce several engine failures. This picture shows a badly damaged piston that indicates the effects of long-term engine knock. The specification which controls and limits the knock phenomenon is called the octane number. Octane is a comparative measurement carried out in the lab with a specific engine. There are 2 methods, one for RON, research octane number, one for MON, motor octane number. The principle is the same with the same engine, only the engine setup changes in terms of specification. Both RON and MON can be required, as in Europe. RON is always higher than MON. The anti-knock index is sometimes used, as in the United States. It is the average of run and mon. When the octane number increases, the gasoline has a higher knock resistance. At the pump in Europe, it says unleaded 95, it means the run is higher than 95. This is the regular value. In the United States, when it says 87, it means that the average of run and mon, the anti-knock index, is higher than 87. In the United States, octane limits are set and regulated at the state level. The industry anti-knock index standard is generally 87 for regular fuel, 89 for mid-grade fuels, and 91 for premium fuels. In Europe or in Asia, it is the minimum run which is indicated at the pump. This map shows the octane limits in several countries all over the world. Have a break now and take time to look at this map. Let's now have a look at the cetane specifications. For this introduction course, just remember the cetane number is the opposite of the octane number. Cetane characterizes the ability of the diesel fuel to auto-ignite. A diesel engine is a compression engine where the air-fuel mixture auto-ignites. To control the combustion, it is important to master the auto-ignition delay and consequently the cetane value. Two types of cetane requirements exist. The cetane number, which is measured in a specific engine, like the octane number, and the cetane index, obtained by calculus. The cetane index is always lower than the cetane number. On this map, the minimum cetane number requirements are presented for several countries. You can see that the limits are very different all over the world. The fuel specifications can contribute to the reduction of pollutants in the atmosphere. One of the main improvements made over the past few years concerns the decrease of sulfur in the fuels, as presented on this figure for diesel fuel in Europe. Indeed, in less than 15 years, the sulfur limit was divided by 50, and now in Europe, the specification is less than 10 ppm or parts per million in weight. Sulfur from fuels has a direct impact on environmental emissions. It contributes to sulfuric emissions, such as sulfur oxides. Moreover, sulfur is a poison for the after-treatment systems, which are used in many vehicles. In Europe, for instance, the sulfur level specification for Jet A1 is 3000 ppm weight. For heating oil, it is 1000 ppm weight, and for diesel oil, 10 ppm weight. Sulfur specifications vary depending on the area of the world. This map presents the maximum sulfur limit for gasoline all over the world. The last specification we will discuss together is the co-flow behavior of petroleum products. For instance, in an airplane, the outside temperature is around minus 50 degrees C during the flight, while Jet A1 must stay completely liquid under these severe conditions. Another example, to ensure cold start and operation of a diesel vehicle at low temperature, it is crucial to master the behavior of diesel fuel at low temperatures. Some diesel fuel compounds, called waxes, may crystallize at low temperature and consequently clog the diesel filter, as presented on this picture. Don't worry, this picture was obtained with diesel fuel, especially made to produce the worst case in terms of co-flow properties. Imagine the trouble you may have with such a clogged filter. Co-flow properties of diesel fuel are described by the cloud point. For the cloud point, a diesel fuel sample is slowly cooled down and its visual aspect is observed. Okay? So when a sort of cloud is noticed, this is the cloud point. When the diesel becomes solid and cannot flow, this is the pool point. Different types of tests exist to determine the co-flow properties of petroleum products. The test and the specification depends on the product, the country, the climate. They are not the same all over Europe, for instance. This limit also changes with the season. Take time to read the table, which summarizes some specification applicable to France for co-flow properties of Jet A1, diesel and heating oil. To conclude on specifications, I would like to add that an important department of a refinery is the laboratory, which performs hundreds of analyses every day to check all the specifications of all the products of the refinery. You will have the opportunity to discover and to discuss with the laboratory engineer during the evaluation games proposed at the end of my second video. But to finish the first video, I would like to discuss the first objective of a refinery. At the outlet of the distillation unit, the products do not respect the specification of the final commercial products. For instance, the sulfur content of the gasoline or diesel fuel at the outlet of the CDU is much higher than the specification of 10 ppm weight. Likewise, the octane number of the gasoline is far below the 95 RON targeted in Europe. Of course, by the selection of crude oil, you can improve the quality of the products. For instance, by selecting a low sulfur crude, you can improve the sulfur content of the products. But in many cases, this is not enough. And you need to treat the different cuts from the distillation unit in dedicated refining unit to improve the specifications. For example, to decrease the sulfur content of the products, we treat the gases from C1 to C4 in an amine unit to remove the sulfur compound. For gasoline, diesel and heating oil, the sulfur level is decreased in a hydrodesulfurization unit called HDS. The octane number of the gasoline from direct distillation is around 30 to 50. To increase its run, the gasoline cut is treated in a reforming unit. Other specifications we have discussed together, like density, cetane, cold flow properties, are obtained by the selection of the crude and by operation of the crude distillation unit. In conclusion, the objective of a refinery is to operate all the units like the amine unit, the HDS, the reforming CDU, VDU, to obtain the final products at the right quantities to meet the market demand and at the right specifications. So, this is the end of the first video on refining processes. In the second video, I will continue to review the objectives of a refinery, and then I will describe in detail the processes of a refinery. See you soon. Bye bye.